and LCR meters and all sorts of that good stuff. Oh, there we go. And then one of the yeah, we can put a pencil around it, you wire. What they're doing. It's too many too like. I get that. Use that file. And LCR meters are in here. Down here. 477. Oh, you're not. Each bench needs an LCR meter. And then could someone put 2 alligator clips on each bench? Here. Two per lab station that you're looking at.
So this one is done, so we have to go to the next one.
So now they're just gonna use 2 other plates.
It's an over and
Yeah.
I guess they're only getting one. Here's the password of one card was. Look at this party.
We're not with the singular other metal plate.
Yep. Those are meant for the inductor.
Well,
Oh, this one.
Well, for the induction.
Doesn't describe the forward onto the metal. I'm just gonna go put the measurements on the board.
Oh, there's another now. Oh, we go.
Oh, here, this one's good. I just need to put the measurements up on the board.
You don't have an odd amount though, right?
Oxide, I don't think so.
Okay. You don't have one left.
and then if you want to get started on.
How's it going, everybody? So far, so good. Thank you to everyone's help for having the practical go smoothly. I really appreciate everyone that helped out with that. GTAs, let's get those graded as soon as possible. It'd be great to have those handed back during lab this week. Okay, they honestly don't take too long to grade. You'll often see the same mistakes over and over and over again, so it doesn't take too long. please get those done as soon as possible. Everyone, this week we are going to be changing up lab partners, so please make sure you encourage your students to swap partners. That means probably moving to somewhere else in the lab. If you notice people that have been working together for the entire semester, please tell them to switch. It's a really important thing to have people learn how to work with other people. So that's what we're going to be trying to do here. I'm going to go get the graphite lead and we'll go ahead and get moving. Any questions for me and any administrative things right now? No? Please keep up on your grading. We had a lot of great help getting us caught up. GTAs, please make sure you publish to Brightspace after everything is graded. They don't happen automatically. I thought they did. I was wrong. So we need to physically push publish after both publish. That will actually display the grades to the students. Then we need to post to Brightspace as well. So please make sure you're doing that. Sound good? All right. I'll be back in a couple minutes.
We have the practical Excel, the answer Excel last semester. You want to send that to our GT? You remember?
If I can find it.
I have that.
Oh, yeah, please. Yes, please do. Thank you.
Yeah, so for the practical, I think we have there's the Excel, so made for all the 10 different version. So you can just,
You want me to go put that in with the answer keys right now?
yeah, or I can send that. So for that one, you can just input type in the rload value, then it automatically give you the answer for each 10 version. So that will be easier when you do the grading. All right, so let's talk about this week. Okay, this week will be the inductor and the capacitors. So, so I think this is probably the first time. I'm not sure they learned that in the 2001 or 201, but probably this is the first time they're going to learn the inductor and capacitors. As Ben mentioned, we will have new partners, or students will have new partners. All right, and okay, so for the capacitor, capacitor for their task 1, they are going to either use this metal plate, okay, or they are going to use this large circle thing. So when if they are using this metal plate, one way easier they can do the measurement is they can put this metal plate like at the edge of the table, and then use the gravity to stack them together and put a paper in between. So then they can measure the capacitance by connect. There are 2 wire on it. Okay, so if they are using this one, that's the way to do it. If they are using this one, they can just put them together like this. And I think when they measure this, they need to attach on the metal part. Okay, so this surface, I think it feels like it's a plastic, right? They need to connect this thing right here. Yeah, they need to connect this connector right here. So then they can get the capacitance. Right, so that's the capacitor they're going to make. And then okay, so this is the capacitance relationship is, I think you all know that you can mention this to the student. The parallel is just C1 plus C2 when they have parallel capacitor. The series is the way they calculate the resistance like parallel. So it's just inverse with resistor calculation. And also they can make a voltage division circuit by using capacitor or inductor. Just make sure it's not working for DC, it's only working for high frequency, or at least some high frequency signal. All right, so this is inductor. Okay, I will mention about the inductor later. Okay. And the inductor calculation is same way as the resistor. All right, so this is let's talk about this one after I talk about task one. So task one is they are going to manually measure a resistor, capacitor, and the inductor. So let's say step one of task one is measure the pencil lead. Okay, so I think the most common pencil lead they're going to use is 0.7 or 0.7 millimeter or 0.5 millimeter. So the 0.7 and 0.5 millimeter is the diameter of the pencil lead. Okay, so some people may think that's it's the radius. It's actually the diameter. So make sure when you do the calculation, you put the equation correctly. Let me see. Okay. Yeah.
Also, can I throw in one?
Yeah,
footnote?
yeah.
When they're measuring the resistance of the pencil lead, make sure they put the little probes and stuff as far away as they can. Because if they measure, for example, just like the middle third, we will see very high errors in this lab. But for example, if they measure just like the middle third, they're only measuring the resistance of the distance between the probes. So either tell them to connect the probes and measure the distance then, or work to connect the probes as close as they can to the ends.
Yeah, so this is the equation they are going to use for the step one. So area is they can use the pencil lead diameter, 0.7 or 0.5 millimeter. The length is, as Adam mentioned, is actually the connection point. It's not the total length. If they are using the total length of the pencil lead, the area will be larger. So try to measure the distance of two connection points, not the total length. So yeah, that's the task one. And also make sure to show the students the pencil lead is very fragile. So be careful when they do the measurement. Then the step number two is the capacitor measurement. So as I mentioned, they are going to use the metal plate to make a capacitor. And it's already mentioned on the menu. The thickness of the paper is around 0.1 millimeter. So that will be the distance of two metal plates. And the area they are going to, it's already written here, but we have the ruler so in front, so they can borrow the ruler and manually measure the area of the capacitor. Okay, so all right, and also so the paper, with the permittivity of the paper should be around 2. Yeah, it's about 2.3. So, but they can just find this value online. I can write down this here. The paper markers. Yeah, so the permittivity of the paper should be around 2.3. But you can either tell them, I think, or you can just let them search online. And yeah, that's step two. Okay, and then step three is the inductor. Okay, inductor. Instead of they're going to make it, we already make it for them. I think you all already see that. So they are going to use this small inductor here. So you also see this, and you saw there's the alligator connection. Okay, so like this, they can just easily connect this here and use the LCR meter to measure the inductance.
If you guys could wipe the ends off a little bit with your hands, they still have some carbon on them. I just burned off the enamel, so there's probably a black stripe on it right now. just take your fingers and rub that across, it should get rid of that.
And also too, if need be, like even just the back of a key, to give it, to scrape it a bit works really well.
Yeah.
It should work out to be about 5 microhenries if you want to do the math yourself. I tested about 2/3 of them, and they all came out to be within about, 20-30%, which, if you guys took this lab last semester or the last semester before and actually made the inductors, that's not bad. So we were talking about 150% error last time, so we're not there. So,
So, yeah. So this is the equation for the inductor. So I think they need to manually count how many turns on this inductor. I think it's, I don't know. 19, but yeah, they can just manually count the turns. And then for the R is the outer radius of the inductor. So they can use the ruler to measure it. And for the small R is the radius of the wire. I think we are using the same one.
Yep.
So the radius is about 2.2 millimeter. This is a value you can just tell the student. Okay, so there's no way they can measure this radius. Yeah, I think as Ben mentioned, since we are using the same inductor, so everyone should get a pretty similar inductance. So they are going to measure this inductance with just air fill inside, and then they can use the screwdriver in their lab kit and put that into the inductor. Something looks like this, and then they can measure the inductance again. So the value will be different, and when they take the ratio of two inductance, they should get the permittivity of the screwdriver, or should be the conductivity of the screwdriver. And the value I think they get from previous semester should be check.
I think it should be between like 4 and 7.
Yeah, something like that. Yeah, I think the guy is something around 3 or something like that, like 3, 4, 5. I think that all should be work. The material of their screwdriver should be stainless steel, but I think as long as they get some like ferrite metal, that's all count correct. Okay, they can just search there are some like permittivity or the conductivity list online, so they can find whichever the metal is for the screwdriver. All right. Okay, I think that's all for task 1. So we will expect a large error for task 1. So I think right now will be better since we are using a standard inductor. But still for question number 2 and question 1. Question 1 should be better, is a pencil lead, as long as they measure the connection point. So the error should not too large. The inductor one might be okay since you're using the standard one. The capacitor one probably will be a little bit larger, but I think they will not get like very large difference. Like they measure 1 micro and then calculate like 100 microfarad, then that's something wrong. Okay, probably they can measure like 1 or like 2 nano and they calculate 5 nano. That's okay. Or any question about task 1?
We do have a dozen cases of lead out here right now. We're using the 0.7 millimeter HB lead. If we run out, there are 2 more boxes of about another dozen or so of these. If you notice that the lead is getting to like half its length, let's go ahead and just not use that anymore and grab a new piece of lead. Okay?
Yeah.
Are these gonna be in 236 though?
Not as of right now.
Yeah.
Soon though. I'll make some more.
Or I think since this is a task 1, they should
They should hopefully.
finish this in the lab. And I think how many we made? I made 40 of them. So we have limited. So make sure after they finish, they leave it on the bench, or probably they can return in the front. But for the ruler, they can borrow this and make sure after they finish, put it back to the front. All right, so that's task 1. Then task 2 and task 3 should be pretty similar. They are going to build this circuit. Okay, it's just a sense resistor with a device under test. It's a resistor. I mean, it's an inductor or capacitor. So they are going to build this circuit and measure the voltage cross at this point, and also measure the voltage at this point. So the channel 1, okay, or the probe 1 is the voltage cross both resistance and capacitor or inductor. So the oscilloscope, you all know that it cannot take the differential measurement. So to get the voltage cross the resistance, they need to use the mass mode or mass calculation. So the mass function is just at the right here. That's a mass function. So you press this, and if they build the circuit as I showed before, so the channel 1 will be the total voltage of resistance and the capacitor or inductor. The channel 2 will be the voltage across the device. So they can use channel 2 measure, channel 1 minus channel 2, like this. Then they can get the voltage across the resistance. Okay, so the voltage cross resistance and the voltage cross the device, which is the capacitor inductor, is what they want to get. Okay, and after they get those two waveforms, the waveform should be looks very similar with what they did in the pre-lab or the question number 2, or they should familiar with the example 7.4.1. Okay, so as long as they're familiar with this this example, they should able to calculate the inductance and the capacitance. Yeah, so just make sure you can tell the student to review this example. And also, since they already did the pre-lab, this problem, so they should already check this problem. Let's see, let me see. Okay, I think in task 3, okay, one thing I want to mention is in task 3, in last semester, we dropped the handmade inductor. Do we still want to drop that one? Ben is here, not here. Okay, I will. So last semester, task 3, question number 1, is measure the inductance of the handmade inductor. So it's what they made at the beginning of the class. We dropped that one because they made different capacitor. Inductor. The value is totally different. Ben's not here. I'm not sure we will drop this one or not, but I will send out an email once I confirm this. But at least for task 2 and task 3, the measured value and the calculated value should be very close. Okay, like less than 10%. Okay, so, and if they get a very large percentage of error, that means they probably did something wrong. All right. Any question about task 2 and task 3? Okay, basically, the measurement process is same, and it's just they apply a different equation. The task 2, they apply I equal to capacitance times dV divided dt, and the task 3 they use another equation. Okay, so one thing I forgot to mention is when they get the plot, okay, they will get like two sine wave with like 19-degree phase shift, which means one is sine wave, another one will be cosine wave. For the calculation process, they can choose either one as sine wave and another one as cosine wave, then they can take a derivative. But it will be easier if they choose the sine wave to do the derivative. Okay, so then the sine wave, the derivative of the sine wave is just there's a ratio at front and times cosine wave. If they take a derivative of the cosine, there will be a minus sign or negative sign. So that's maybe harder for them to do the calculation. And that's one thing probably you want to tell the students. But are we going to drop the inductor measurement for the handmade one?
So that's what the handmade one is for as well. So you do it once with one from your kit and they do it.
Okay, so we will still do it. Okay, so then never mind. So for the task three, they will still measure the 1 million Henry capacitor, inductor in their lab kit, and also they will measure this capacitor, this inductor, the handmade one.
Hopefully we should get some more consistent values.
Yeah.
Pretty close to the same.
Okay, yeah.
Not
Right, so that's task 2 and task 3. Make sure you tell the students they need to use math mode to do the measurement. Okay, the oscilloscope didn't take differential measurement. Okay, any question about these two tasks? And then the last one is they are going to use the capacitor to build the voltage divider circuit. I need for the circuit right here. Okay, one thing I forgot to mention this in the task 2 and task 3, there's no ground sign in here. But make sure, like as I mentioned before, tell the student all the ground connect together. Okay, so this task they are going to use the function generator. There's the ground. They're going to use the oscilloscope. There's the ground. Make sure they connect all the ground together. Okay, and for the oscilloscope, they can't just use connect one of the ground because the internally the oscilloscope ground is connect together, so they don't have to connect both of them. If they won't do that, it doesn't matter. Okay, then the task 4, they're going to build this circuit right here. The common question they have is the RS, and the RS is actually the internal resistance of the function generator. So they don't need this RS on their breadboard. Okay, and then they are going to use the oscilloscope. So like the channel 1 is measure the input, the channel 2 is the output. So this is the negative of the proof. So they're going to do something like this. 1. So that's the circuit they're going to build. And let's see. Okay, so for so step number 4 is after they do this connection, they capture the screenshot. And step number 5 is swipe the C1 and C2 position. So then they take another screenshot. And step number 6 is they sweep the frequency. Okay, so from 1 Hertz to 1 kHz. Okay, so when they have, they probably will start with like 1 Hertz, 10 Hertz, and then 100 Hertz. When they have very low frequency, let's say something like, let's say 1 to, not sure, like 13 hertz. Under this frequency range, they probably want to use the row mode for the oscilloscope, okay? If they have 1 hertz, they use the normal mode, the oscilloscope is not going to work. Okay, make sure they're going to use the row mode for this. Okay. And the answer for this question is when they sweep the frequency, the attenuation ratio doesn't change. And also one thing you want to mention is the attenuation ratio is just the way out divide, way out divided way in is the attenuation ratio. Okay, they don't know what's the attenuation ratio. And then the last question is they sweep the voltage the function generator to a DC voltage source, then the the voltage divider will not work because capacitor block all the DC. Okay. I think this is the first time they are going to use capacitor, so this part can't relate to the impedance of the capacitor or inductor. So I'm not sure they learned this in the 2001 or 2001. You can like quickly tell them how the inductor or capacitor is, the impedance is vary with frequency, with different frequency. Or you don't have to talk about this. It depends on you. Right, I think that's all for lab 7. I think overall this lab should be pretty quick, and the most time consumption part probably will be the task 1. They spend some time to make the inductor last semester, but since we have the standard inductor, this semester will be better. Adam, do you have anything to add?
Yeah, I think that's all I have to add. The only thing would be, in the last task, when it says sweep, don't actually put it as like a sweep mode on the function generator, just have them, manually adjust. But that would be the only other comment I have.
Yeah, one thing is the actual credit gradient. Okay, I think some GTA may forgot this is because the actual credit we submit on the Brightspace, so it's very quick to grading. So just make sure you're grading it on time, and also make sure you remind students this week they need to submit the Lab 5 report. Okay, start tomorrow. Remind your students. Okay.
GTAs, please make sure you only have one assignment on Gradescope for Lab 5. I saw a couple people still had 2 assignments there. We're only doing 1. So the writing TAs got added to Brightspace last week. Refresh your roster and they'll pop up in Gradescope. And then change your grading scheme for Lab 5 to be the 75% of the actual grade of the lab itself, and then 25 will be writing. Sent that to you guys in an email. Please do that as soon as possible if you haven't done so already, and remove the other Lab 5 assignments. Go ahead.
One more quick thing. Some people today in my office hours were asking about like the Lab 5 templates and stuff. So if those are not yet on your Brightspaces, please be sure to put them up. And preferably do that as quickly as you can.
They should be on a link already in content, but if they haven't downloaded yet, then they're probably not going to. So please just post it some more. So, thank you.
Can you send me the lab materials? I don't
I
know.
also want to say thank you, Bryson, for
Okay.
all the work you did on updating all the templates
Access to the.
for this semester and next semester. So thank you so much for that.
Okay. Yeah, I
That'll
can send
make
this to you.
your grading go a lot smoother.
All the stuff.
Okay, hey, real quick, GTA is up here, real quick, please.
Yeah,
Just a quick question. Thank you. Everyone's already leaving. Go. Cool. Sorry about that. I meant to say something earlier. First off, things going okay? So far, so good. Cool. Practicals are okay with everyone? Awesome. Please get those there as soon as possible. If we can hand those out this week, that'd be great. They don't take super long. The Lab 5 reports will take a minute. Super concerned about getting those out right away, but again, the sooner we can get those out, the better. For Gradescope and Brightspace. Gradescope doesn't export a percentage. It only exports the point value that you give it. So for example, Lab 2 was only out of 80 points on Gradescope, so it only exported the numbers. So say they got a 75 out of 80, it exports a 75. And the group on the assignment on Brightspace is out of 100. So I need you to do one of two things. Either update the grade on Brightspace to be the same point value as it is on Gradescope, or, and this is what I'm personally doing with my sections to give them the benefit of the doubt, I'm just giving them an extra 20 points on Brightspace to bump it up to 100 points. Personally, that just seems a little bit easier, and that's also on me because I didn't set that up properly. That's kind of my fair play there. I'm not sure if you guys saw Piazza last weekend, but we're getting kind of salty about the syllabus agreement because they thought it was worth a very large portion of their grade, and apparently very large is 0.4%. So, and part of that is just because, again, grades are not exporting to Brightspace automatically from Gradescope. So please make sure you're posting that. If you notice, people did submit the syllabus agreement up until Saturday of last week at noon, give them 75% credit. That was the agreement that we did to. And the assignment not being set up quite right. Yep. Yep. And the demo. So still pass. Thing is, that is something, if you go, when you start looking at the grades, so say they got, less than a 50 on practical and they've been struggling with the previous assignments, it might be worth either sending them an email or sending me an email, contact info, and it might be worth reaching to say, hey, probably not what you want to hear, but based on what you did on the practical and your previous assignments, it might be worth it. So we're up into that point. I believe the last day to withdraw is March 11th. So just getting close to that time. We're not super close yet, but it is coming close. Start seeing that when you're grading your practical, keep an eye out. Sound good? Cool. Any questions for me? Yep, I will be sending out that schedule to you guys first, and again, that's just a quick checkup on you guys, see how things are going on an individual basis. I'll be sharing that out to the undergrad. Again, I'm relatively new to this position still. It's always good to get other meetings. It's also, again, just to say, check just to make sure that they're hopeful. Cool. Anything else for me? Have a good week. I'll be around frequently as I can. Quite a few meetings that just kind of bogged up into this week. Trust me, I'd rather be. So, I'm good. Have a good one, guys. Yep.
Yeah. I will send out today, so. Oh, I saw your. Thanks.
You verify this whether everyone attended the exam?
Oh, I didn't work, I didn't count this. Do you know how many students will? Exactly. Okay. But it should be the everyone in the lab. Yeah. What?
I need materials for this lab. I
You
don't,
mean this or?
no, other stuff on right place.
Okay, the PPT stuff. Yeah, I can send you PPT. Yeah, just,
Not the PPT. Can you log into your Brightspace? I'll show you.
you can.
To put on Brightspace. I have no access to Brightspace.